Congratulations on making it through the previous 3 sections. In the last section, we talked about how to visualize our network using TensorBoard in the form of graphs, histograms, and scalar summaries. In this section, we'll look at some of the advanced stuff by processing more complex and detailed images using a well-known concept called convolutional neural networks, aka CNNs. We'll revisit fully connected layers, where each node on a neural network is fully connected to the previous layer. We'll then explore a neural network architecture much better suited to image processing, convolutional neural networks. We'll actually program a CNN on TensorFlow and finally analyze our project using TensorBoard to view our new network architecture and compare the performance of our new architecture from the previous fully connected architecture. In the first video of Section 4, we'll look into the concept of fully connected layers. This is the stuff that we've been doing in the last 2 sections. So, let's get started. Let's take a look at the following stuff in the next portion of this video. We'll talk about what are fully connected network layers and what are hidden nodes, and why we should use them and why not. Then we'll talk about the previous code in which we had implemented a fully connected network using 2 layers. Fully connected layers connect every node on the previous layer to every node on the current layer. That's all we've seen so far, so it seems normal, but it's not. We'll see how convolutional layers connect specific subsets, often spatially oriented around pixel neighborhoods. In the diagram, we see 2 fully connected layers between the input and output layers. You'll see many variations of this. Often the fully connected layers will show up at the end of the series of layers. In this diagram, you see another network architecture, except this one has several fully connected layers and far more nodes on each of these layers. The number of nodes is irrelevant for the fully connectedness, of course. Only the connections to the previous layers are important in this definition. Sounds easy enough, except that these are not ideal for images. They work as we saw on our first project with character recognition, but they don't work as good as network architectures, where the proximity of pixels is also considered, i.e., we need to find patterns and shapes in the images to better understand it. The network has to see how the pixels are arranged in the inputs to make a pattern out of it. We'll see an alternative soon that not only considers pixel proximity, but also convolves across layers to compose larger features from smaller ones. Sometimes we need to extract the features that make up the whole object. Till now, we're looking at the image as a whole. If we have a cropped image, we won't be able to classify the actual object easily. We need to look at the individual features of the object, such as what type of curves and lines make the letter A, so we're able to classify objects even with partial information. The point of having more layers in between is to make a better approximation of different types of the same image. For example, if we want to recognize a car object, but they're in different orientations and colors in the dataset we have, then the individual hidden nodes in the in-between layers act as a whole image object feature recognizer. So we can have a hidden node which is only looking for blue cars, and the other one only looks for red cars, and another one looks only for cars facing front, etc. Then all of these nodes sums at the end to give you the actual classification at the final layer, in which you have equal number of output nodes as you have classes. This is obviously better than having only one node, like we've coded before, for each different class we have in the dataset. Keep this in mind that we're almost always going to use fully connected layers in most of the neural networks, as they're kind of the only way to do a weighted sum on the extracted features from the previous convolutional neural network layers. Don't worry if you don't understand much of what I just said. You're going to know what we talked about here in the later videos of this section. In this video, we've looked into the concept of fully connected layers and have talked about the difference between multi-layer fully connected networks and how it was differentiated between the one we've implemented before, in which we didn't have hidden node layers. This is a little overwhelming to understand, but we're going to break it down in the later videos. In the next video, we're going to talk about the very famous deep learning concept, i.e. CNNs. See you guys there.